Hey, welcome back for another reading of a time series abstract from NeurIPS 2022. This one is called Multivariate Time-Series Forecasting with Temporal Polynomial Graph Neural Networks by Yijing Liu et al. And they're going to be talking about the framework, we'll be talking about the framework of TPGNN. We proposed, they say that they propose to represent the variable dependence of multivariate time series data as a temporal matrix polynomial, where the effectiveness of our method is validated empirically and theoretically. And their abstract. Modeling multivariate time series MTS is critical in modern intelligent systems. The accurate forecast of multivariate time series data is still challenging due to the complicated latent variable correlation. Recent works apply the graph neural networks, GNNs, to the task with the basic idea of representing the correlation as a static graph. However, predicting with a static graph causes significant bias because the correlation is time varying in the real-world MTS data. Besides, there is no gap analysis between the actual correlation and the learned one in their works to validate the effectiveness. This paper proposes a temporal polynomial graph neural network, TPGNN, for accurate MTS forecasting, which represents the dynamic variable correlation as a temporal matrix polynomial in two steps. First, we capture the overall correlation with a static matrix bias. Then we use a set of time-varying coefficients and a matrix basis to construct a matrix polynomial for each time step. The constructed result empirically captures the precise dynamic correlation of 6 synthetic MTS datasets generated by a non-repeating random walk model. Moreover, the theoretical analysis shows that TPGNN can achieve perfect approximation under a commutative condition. We conduct extensive experiments on 2 traffic datasets with prior structure and 4 benchmark datasets. The results indicate that TPGNN achieves the state-of-the-art on both short-term and long-term MTS forecastings. Okay, and they have a GitHub page that I'll put in the link in the description. Here is their figure 1. And I'm going to show you the conclusion. I'll show you some of their figures as I go down. This is the framework of the TPGNN. And let's see, some tables. Figure 3. And their conclusion reads, we propose a novel GNN based method for MTS forecasting, TPGNN, which represents the variable dependence as a temporal polynomial matrix. The results on 6 real-world datasets illustrate the outstanding forecasting performance of TPGNN. Besides, extensive experiments on synthetic datasets demonstrate that our method achieves the best dependence approximation than other baselines. All right, I also have a link to some other abstracts that I've been reading, a playlist to those abstracts in the description. And they have some slides. I'll show you them real quick. And I encourage you to check these out on the NeurIPS website. From the links in the description. And I'll also put the GPU they used in the description. All right, guys. Thanks for listening. You have a good day. Take care. Bye-bye.